Okay, to start today, I want to correct the end of my video from yesterday. The very last few minutes, we were going over an hour, and so I said for a pyramid, for a rectangular pyramid to find the surface area, and for a square pyramid to find the surface area, you can use the same formula. I was in error when I said that, because we started to try to work one of those problems, and it ended up that the rectangular pyramid won't work with this formula. So the correct information is you still use this formula for surface area of a square pyramid. That means that the base is a square, okay? But if we get to the rectangular pyramid, here's how we figured it out. Because the formula here for the surface area says to use the slant height, which is going to be the same all the way around a square pyramid. But then when we came over here, we found out that we have different slant heights and didn't know how to handle that. So what we decided, and I've looked online to make sure, I've looked everywhere that I can see, and definitely not on your formula chart, is a formula for finding the surface area of a rectangular pyramid. So here's what we're going to do that. We are simply going to tear it apart. We're going to tear this rectangular pyramid apart and work on the pieces, find the area of each piece. So here we go. Let's start with the base. Here's the base. And you can see, although it looks squished over, it's a rectangle. And so we're just going to draw a rectangle. Now the dimensions, let's go ahead and put the dimensions on this. It's going to be a 16 by 8 foot. Vanessa, watch and make sure I put the right numbers. Okay. By 8 foot. Okay, we've torn the bottom off. I want to tear the front off. So here's the front of the pyramid. And it is 16 feet by, and the slant height that comes out on this triangle is 11 feet. Now, if you'll notice on this rectangular pyramid that the front piece, and when you tear the back piece off, they're going to be exactly the same. So we're going to find this area, and we're going to take it times 2, because there's a front and a back. This is the base. Now you can see that we have 2 more. We have a triangle on the side, and the triangle on the other side is going to be exactly the same shape, okay? But they have different slant heights. So what we're going to do here is draw the sides. This is the side and the side. Because they're the same, we're going to take it times 2 when we're finished. Now, you can see, if we look here, this triangle comes up off of the 8. So this triangle comes up like this. Okay? So this is 8 on the bottom, 8 feet, and its height, the slant height of the pyramid, is 13 feet. Now we have, if you want to make sure that you have all the sides drawn, then you have the base, and we have a triangle coming off each side of the base, coming up to a point. Y'all see? So I have 1, 2, 3, 4, and the base makes 5. So the pictures I have are 2 of these, and 1 of these. I've got all my pieces. Is everybody okay with that? All right, and then all we have to do is find the area of each piece. Okay, so how do you find the area of a triangle?
1/2
Base times height. So if you take this, 1/2 the base times the height, the area for this is going to be 88. And we're going to take that times 2 in just a minute. Now let's find the area of this triangle. And again, it's going to be 1/2 the base times the height. And so we're going to go 4 times 52. So the area of this one will be 52 times 2. And then the area of a rectangle is simply length times width, 16 times 8. And we're going to have 128, I'm pretty sure. So now we found the area of each individual piece of this pyramid, and we simply add them together. So I've got 128 is the base, 88 times 2. I can either multiply those together or 2 88s, right? An 88 and an 88. And this one will be 104, I think. Y'all check me out. So 408 feet squared, correct answer for this problem. Right. This is off the other one that I gave you already, the one I gave you yesterday. So understand the difference. I want to make it clear because I made a mistake when I spoke at the end of yesterday's video. This formula that I gave you in yesterday's formula is just fine to use to find the surface area of a square pyramid, meaning that a square is the base. That means all the sides are equal, which means all the slant heights are going to be equal. But when we hit the rectangular pyramid, all the sides of the base are not equal, which means all of the slant heights are different. So in a rectangular pyramid, you're going to have to take it apart and find the area of each individual piece, then add them together. Any questions? Okay, I think some people here are maybe needing, do you need a picture or anything? Y'all?
Let me go ahead and take one.
And then we'll start on the next. Uh-huh. That one is the square pyramid because the base, all the sides are equal. Okay, on to our new subject today. It's not horribly new, but it's a different area. We're going to talk more about geometry, but now we're going to get into lines and points and rays and planes and angles. Today, we will be using 2 different packets, and those of you that are remote students, I'll be sending you those packets as soon as I'm done here today. Okay?
Okay.
All right. Most of what we're doing today is small definitions. I need you to understand those, and I need you to understand how to write things. So where did I put my packets? Here we go. So we're going to start with something as easy as this, a point. Okay, a point is any location in space. It's just a place in space, okay, a point. Now, I'm not going to write out definitions because the papers I'm sending you has a definition on it. This will be the start of the packet.
Okay.
So it has the definitions. I'm not going to write these out. I will talk about them, but I won't be writing them out on the board. Okay, now, so a point, location, anywhere in space, anywhere. Okay, now, a line, believe it or not, the definition starts out here, and I do want to say this. It starts out as a set of points. Now that sounds weird, but this is the one thing that I think you need to get in your heads, is that this isn't, it isn't actually a stick, a line out in space somewhere. This is a set of points. Now here, I had a hard time understanding this the first time I heard it, but I was taught that here is some point somewhere in space, right? And then here's another point somewhere in space. And here's another point somewhere in space. And here's one, and here's one, and here's one, and here's one, and here's one. And do y'all see that in between those points are more points? There's an infinite number of points, and any set of points that are in a straight direction like this create the line. Y'all see? So a line is actually an infinite number of points. Okay? Now, you will also want to know that a line extends indefinitely in both directions. This is a line, as opposed to a segment. A segment is also a set of points, infinite number of points, but it is only a part of a line, and it has a stopping place on each end. This is, I guess I would put this. This is a line. This is a point. And this is a segment. Okay. And now we also have a set of points that has one end point but extends indefinitely in another direction. Okay? Now it can have the point on the left and to the right, or it can have a point on the right, extend to the left. But this is also a set of points, but this time a ray has a stopping point, one stopping point. Segment has two endpoints. A line has no endpoints, which means it goes on forever. Ever and ever and ever and ever. Okay? Definition. And it'll be on your handout, y'all, on remote, and y'all are seeing it there. Are there any questions on the definitions right now? Okay. Then we move on to a plane. This second one is, it's the same definitions, but it tells you how to write. If you're going to talk about array, or if you're going to talk about a segment, how to name it. And we'll talk about that again. But the one on the second page I want to talk to you about is a plane. Now they represent it like this. And the way that I think about it is a sheet of paper. Just a sheet of paper somewhere in space. But it doesn't stop. It continues. So this is a layer somewhere. Okay? There can be a plane here, a plane here, a plane here. There can be intersecting planes. Okay? But it is, how do they say it? A plane is a flat surface that extends to infinity. So it's exactly like a flat sheet of paper somewhere in space, but it extends forever. It's a layer. Are we good? Yeah. Plane. Don't you love the chalk? Okay, and now, okay, let's go ahead and name these. You name a point by a letter. Most of the time, they have letters. So this is point A, or point X, or point J, whatever. That one's pretty easy. The line will be named for 2 points, and they will be given to you. Any 2 points on the line will name a line. And so let's say, here's a point, and we call this K and M, okay? So the way that you write this, if you want to name this line, then you're going to call it line K M. That's how we indicate what it is. You can also call it line MK. It'll be the same thing. All right? And the same thing is true of a segment. If we call this L and P, this will be segment. Well, you don't have to put the point. It's just a line, and it says LP or segment PL. This, when you don't put the arrows on it, indicates just a segment, just a piece of a line. And the same is true here, except it is important which way you say this. We're going to call it array, and no matter which way it's facing, the first letter is going to be the end point. So you have to name the end point first. And then the other one is on the line somewhere. So this is ray A, B. If we had this and we had J, C, okay, and you would still use the ray. It doesn't matter. The ray, when we're indicating it, always goes in that same direction. But you have to name the endpoint first. So it would be JC. Any questions on these? Now we're going to talk about some more definitions. This next word looks really long, sometimes scary. It's not. Co-linear. So look here, there's line, okay? And there's co, which means a bunch of points on the same line, okay? They all lie on the same line. So A, B, and C are all collinear because they're on the same line, okay? Points can be collinear even on a segment, okay? They're still collinear, which means if we have non-collinear, that means they're not all on the same line. They're non-collinear, okay? And the same thing is true with coplanar. You see plane here, and co, on a plane somewhere in space, we have points that will be on the same plane. Okay?
What about that T? Is that T?
I
Something
think
they don't mention it.
I think that's how they named the plane.
Okay.
It's plane T. And I'm not sure, did it tell us how to name a plane?
Mhm.
It just, on the one before, you're just naming the plane with 3 letters. Oh, the part that's cut off. See, it says, on the plane, it says plane EFG. You're using 3 points to name it. Or plane, it should say T. Okay. Okay, the question she asked on your handout, it has E, F, G, and it has another one. Yeah, E, F, G. And over here, it kind of has a T. And they said the way that you name this plane is plane, no picture, plane, and you use 3 letters. Because that defines only 2 letters defines a line. So you have to have 3 letters to define a plane. Or you can just call it plane T, because they named it plane T. That's not a point. Notice there's not a point there. It's just named plane T. Good question, Naomi. Good, good, good. So if I had another point out here, S, then these points would be non-coplanar because they're not in the same plane. So far, so good? Just a little easier than finding surface area?
Yes.
Okay, so what we found here, I told you that we can have, when we're talking about a plane, that's that sheet of paper. And we know there's a lot of planes all over, you know, in space. So we could have a plane that looks like this. But then somewhere out there is another plane. I hope these are hard for me.
That looks good.
And where they intersect, see, this is where they come together. I think that's right. This is where they come together. So when 2 planes, you'll need to write this. When 2 planes intersect, intersect means they come together and cross each other. Intersect. Create a line. So you can see if you had one plane here and another plane coming down in where it could go actually through, like invisible, it would create a line where they intersect, right? So when 2 planes intersect, they're going to create this line. Understand?
What did you say intersect means?
Intersect means come together or go through. Intersect where they come together, okay? And you can think of planes almost kind of invisible, so it can go all the way through, you know? And the place it goes through is a line.
Like how the planes leave those lines in the sky and they go through, like
No, those would be intersecting lines. This is more like 2 pieces of paper intersecting, okay? Okay, so that next page is going to ask you questions. It says write all the points on plane L. Okay, so do you see on your page 4 that there's, what points would you name on plane L?
D,
Mm-hmm.
B, C,
And
A,
A. M is not a point. Notice there's
Oh,
not
yeah, I
a
didn't know
dot. M is the name of the line.
Yeah.
Okay? They named it M.
So when we write our answer, do we have to write like or draw something on top, or just
You
write?
will when you do a line. You will when you do segment, ray, not point.
Okay.
You just list those with commas. Okay? And again, the answers are on the back, so that will help you.
And on A, it says name the planes.
Mm-hmm.
So
So you could either use 3 points. You could say plane ABC or plane whatever. And then the other plane is going to be BEA, BEC, or you could just use that letter T and that letter L.
on here has a T and the L.
Okay? You can name them like
So
that.
the
But
planes is this, like the flat surface, right?
yes, the plane is that flat surface. Okay, and I've talked to you about the next one, and I've talked to you about the next one. Okay, so I'm just giving you an overview, and then you'll have the handouts. So now there is another definition besides our point and line and segment and ray and planes. We also have angles. Okay, the definition of an angle, this is your other handout.
Okay.
2 or more rays, they may have it a little different wording. 2 or more rays that share a common point. And that point, that common point, is going to be called the vertex. Okay, so the definition of an angle is 2 or more rays that share a common point. And that common point is going to be called the vertex. So, as you write that down, I'm going to go ahead and draw. Here's a ray. There's its endpoint. Here's another ray. And they share the same point. Do y'all see?
Those are 2 rays.
Yes, this is a ray because it goes indefinitely in one direction but has an endpoint, remember? 2 rays. This is an arm. This is an arm. And this point, the common point, is called the vertex. We will be measuring angles later on, not today, but this is the measurement of an angle. This is the measure of the angle. We indicate an angle using this, okay, to tell how big it's opened, okay? And it's measured in degrees. Now, if we have, maybe this is called, and this, there's some point here, anywhere on this ray, and it's a B. I'm going to circle them for all this stuff that's here. And of course, let's make this C. There's a point somewhere here. So to name an angle, you use 3. You have to use 3 letters, and you have to put the vertex in the middle. The outside ones don't matter, the order, but the vertex has to be in the middle. So this would be angle. This is how we say angle. B, A, C, or it can be angle C, A, B. It indicates the same angle. Y'all see?
A always has to be in the middle. For
The vertex has to be in the middle. Now let's go ahead. Up here in the definition of angle, it says 2 or more rays. What if we put this ray here? and it's D. Then I have actually 3 angles in here. I have the big one that we talked about. Then I have one here. How would you name that one? Angle. Oh my, I'm not seeing any of this.
Measure by degrees.
That better?
Yes.
Okay, how would you name this angle right here? Is it B? No, D like a dog. B.
Measure by degrees.
But that's just a point. You name an angle with 3, and you have to A, because the vertex has to be in the middle. So D, A, B. Yes, or angle B, AD. Okay? And then let's name this one. Okay? So that one would be angle
D.
C, C,
D.
A, D, D. Good. C, A, D. We're naming this angle right here. Or it could be angle DAC. But notice that the vertex has to be in the middle. Okay? We actually are almost through with the instruction for today and let you play with this before we move on. Now we're going to talk about the 3 types of angles. Yeah, this is it. Okay, 3 types of angles that you're going to deal with now. This one. We've used some. This one. And this one. Okay, we've dealt with this a lot.
Yeah.
This means perpendicular. But in the degrees, perpendicular also means 90 degrees. 90 degrees. And they probably later on won't even write 90 degrees. If there's a box, it's 90 degrees. Okay? And so the 90-degree angle, whether it goes that way or this way, as long as it has 90 degrees, this is called a right angle. A right angle. You notice here that a right angle would be here. That's 90 degrees. So can you see that this is going to be less than 90 degrees? Less than 90 degrees. We do use the little degree mark. This is called an acute angle. It could be anything less than 90. Any degrees less than 90. Bless you. You must be allergic to me. Are you?
Or to angle.
Yes, to angles. Okay, remember, right angle would be right here. Right? So that's 90 degrees. Can you see that this is larger than 90 degrees?
More.
So an angle that is more than 90 degrees is called obtuse.
What's the little circle they got there in between the 2 arrows in the
The
picture?
vertex.
It's the vertex.
Where?
Well,
Tell
the
me.
picture. In this
Oh.
picture that.
In the
That's a,
acute angle.
you didn't put it on your picture.
The acute angle? Did I not? Oh, yeah. Did
That
I?
little circle in the, right here in the middle.
Oh, on the
Oh,
last
I
one.
didn't put it on the obtuse. That just says this is the angle we're talking about.
Oh, okay.
Good, good. You've got to keep me in line. It's you or Vanessa or Naomi or, you know,
This one makes
Rachel
sense.
or Mary. You guys keep me in line, okay? Thank you. Okay, this one is more. This indicates the angle that we're talking about, okay? Next, later on this week, they're going to start to put numbers in here and tell you exactly how many degrees this is. And we will start to work with that, which leads us right back into the algebra we already know how to do. Okay, we'll work some problems before the end of this week.
And how would that work? Like if they put the number in there, we would have to know what?
Basically how
Mhm.
big it is, or
Uh-huh. But guess what? We also have a little tool that we're going to use called a protractor, and it will help you measure your angles. You'll get to practice measuring your angles. It looks like this. It's a protractor like this, has a bunch of degrees. It has 180 numbers around here, okay? And then you will put your vertex on here, and one of the lines will come out here, and then the other line comes out like here, and you can read what the measurement is right there. The protractor, this will be a protractor, and I have some for you. Okay.
yeah, she's showing them out last month.
Yeah.
She's like, look what you're gonna play with.
Yeah. I made them a long time ago for you. A protractor. We'll be learning how to measure, and then they'll say, well, this is x plus 9. And you'll have to find out what x is by measuring the angle and then saying x plus 9 is this much. So I'll lead you slow,
Okay.
okay? Now on this, I don't know, in grade school, they told, junior high, they were telling us that sometimes people get these names mixed up between acute angle or obtuse angle, and they said, just remember the word cute. This angle is little bitty and cute. It's so cute.
Cute.
And this refers to the name obese. Obese, obtuse, okay. Ta-da. Okay, now there are two more that are listed on here that I want to make sure. I'm the reflex angle.
I've never heard of a straight angle.
You're going to need to use a straight angle, so I will tell you what a straight angle is. Here's the vertex, and here's one of the lines of the angle, right? Here's the other line of the angle. See? And so this is called a straight angle, which means it looks like it creates a straight line, but here's the vertex, here are the arms, and if you measure from here all the way to here, it's going to be 180 degrees. This is always. This is something that you might want to remember now. A straight angle, there is such a thing, and it measures 180 degrees all the time. Never changes. Okay? There's not any, but in this case it might be. It isn't. It's always 180 degrees. Okay? And then they had a complete angle, and I don't know that I've ever taught a complete angle. But here's what it is. Here's the vertex, and there's one side of the angle, right? Here's the other side of the angle, which means that it started here, it went all the way around and came back to the starting place. Okay? And this, what they call it? Complete angle. This is a complete angle. I'm learning lots of new words. And a complete angle that goes all the way around will always be 360. See, it's twice as much as this, because this went halfway. That one goes all the way around. All the way around is going to be 360 degrees. Okay, and the last one that they have on this page is called a reflex angle. Okay, so a reflex angle, and I'll try to write a definition. Okay, let's say we have this angle. This is the angle that we usually talk about, right? What kind of angle is this? Acute. This is an acute angle because it's less than 90 degrees. But the reflex angle is the other way around. It's this angle. Okay? So it's like,
You can turn it like.
It's
spin
just
it
the
in
other
a
part.
different direction.
yes, it went the other direction. This is called reflex. A reflex angle. And this one, let me think about a good definition. It will be larger than 180 degrees.
And less than 360 degrees.
And less than, it's on there? Good, okay. This definition will be on your handout that I sent to you. Okay, a reflex angle is greater than 180 degrees, but less than 360. Reflex angle. Okay? The main ones you're going to be working with are right angles, acute angles, and obtuse angles. Okay? And I think, are you happy to know that this might be it for today? Yes. Tomorrow you will have 2 more packets. They will all have to do with angles tomorrow. Okay? 2, maybe 1. We'll see. Okay. Any questions? Josh, Isabel,
No, ma'am.
doing okay?
Yes.
Okay. I will be sending you these handouts. There'll be 2 separate packets, okay? So I'll probably send them in 2 emails,
Okay.
which is which, and then just staple them together separately.
Okay.
You'll number them, then when we go through and maybe people are asking questions on one of the pages, you'll know which page we're working on because it'll be numbered, okay? I will put the
Okay.
page numbers will be in a little parentheses out in the file name, okay?
Okay.
All right, Josh, are you okay? Josh? Okay, I barely can hear you, but I heard that you were talking. Is everything okay? Okay. I'll be sending these out to you soon, okay? Here
Okay.
within the next hour.
Okay.
All right, I enjoyed it.
Okay, have a blessed day.
Okay, you too. You know I love y'all.
Love
Bye-bye.
you too.
Love
We'll
you
see
too.
you tomorrow.